Hello everyone, good morning. Dear authors and invited guests, welcome to the technical session 4A. My name is Siddhi Auti and I'll be your session moderator for this conference. I, on the behalf of Global LLP, my great pleasure to welcome you all to the 10th International Conference on ICT for Sustainable Development, ICT4SD 2025, Goa, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held in Goa, is being held in Goa today, and the virtual event will be organized via Zoom meetings from 17th to 19th July. I hope you will enjoy the knowledgeable and interactive session throughout the day. In this session, we will be having 10 presentations in total, and each presenter will be given a time span of 10 minutes for the presentation. And after 9 minutes, I will be raising a gentle reminder. The last 2 minutes are reserved for questions and answer sessions. So I request all the participants to please respect the time constraint. There is also another request to all the participants that you stay connected with us till the closing remarks. If you have any query or update, you can write it to me in the chat box. Now, just this session, I would like to introduce you all to the chair for today's session, Dr. Bhumi Gupta.
Good morning, everybody.
Good morning, ma'am.
Good morning, ma'am.
Nice to be a part of it, and my best wishes to all the speakers for the session.
Just a minute, ma'am. We will be starting in just a minute. Hello, everyone. So I welcome Dr. Bhumi Gupta for today's session. Dr. Bhumi Gupta is an associate professor from Maharaja Agrasen Institute of Technology, New Delhi, India. Dr. Bhumi is an associate professor with expertise in civil engineering, computer engineering, and transportation engineering. Her specialized skills include transportation planning, disaster management, and computer communication networks. Dr. Gupta is dedicated to advancing research and education in their interdisciplinary fields. Now, without any
Thank you,
further ado,
Siddhi.
we will start with the very first presenter for today's session. So I request Akanksha Jain. Akanksha Jain is from Yale University, and the paper title she'll be presenting on is a comparative study of deep learning models for food freshness detection using transform learning. Ma'am, if you're there in the meeting, please give me a response. Yes, ma'am, your screen is visible. Ma'am, you can proceed with your presentation now.
Has Akanksha started the presentation? It's not
No,
audible.
ma'am.
Okay.
No, she hasn't started yet.
Yeah,
Uh,
okay.
yes, we are trying to reach. Hello, Akanksha ma'am, we are not able to hear you. Can you please start again? Ma'am, if you're facing some issue with the internet. Hello. Ma'am, can you please start with your presentation? Actually, we are able to see your screen, but we were not able to listen to anything. Your voice was not audible. Ma'am, if you're facing some issues with the presentation right now, you can just get into a stable internet connection and then join again. Meanwhile, we can have the next participant for now. Is that all right? Just give me a response in the chat box. Okay. So we will proceed with the next presenter then. So the next presenter we have here today is Jyoti Prakash Mishra from BITS Pilani, India. And the paper title is A Hardware Security Review of RISC-V. Sir, I request you to please start with your presentation.
Just give me a moment. I'm just sharing my screen.
Yes, sure, sir. I will be raising reminder after 8 minutes.
Yeah, sure. I'll just
Yes.
probably, drop off because my Mac is asking me to open and close it again. Just give
Yes,
me
I've
like
stopped.
10 seconds. All right. Yeah.
Okay, okay.
Okay.
I request all the participants that you may please be ready with your presentation and stable internet connection so we can complete this session on time. Thank you.
Sir, is there an issue with the meeting? If you're going to need some time, we can proceed to the next presenter and then have yours at the end. Is that okay?
Can you hear me?
Yes, yes.
Yeah. Let me share my screen now. Is this visible now?
Yes, yes.
Okay. Sorry for that. Let me start right now. Good morning. My name is Jyoti Prakash Mishra. I'm presenting our work, a hardware security review of Risk 5, co-authored with Sanjay K. Sahai from BITS Pilani and Aman Pathak from K2 University. This review examines the security challenges inherent in this open source architecture. Uh, right. First, so what is Risk 5? It's a free and open source instruction set architecture, or ISA. Its modular design allows for extensive customization from small microcontrollers to large-scale computers. This openness is a double-edged sword. On one hand, transparency allows anyone to audit the design and innovate rapidly. On the other hand, it allows attackers to study the architecture in detail to find and exploit security flaws. Unlike proprietary ISAs, RISC-V lacks a built-in standardized set of security features, which creates persistent risks. The open design of RISC-V exposes it to several major hardware attack categories. First are side channel attacks, which exploit physical information leakage. This includes cache timing attacks that infer data from memory access times and power analysis that can steal crypto keys by measuring power consumption. Second are fault injection attacks. Techniques like electromagnetic fault injection use EM pulses to create errors, allowing an attacker to skip instructions and bypass security checks. Third are system integrity attacks, which target core platform security. These include manipulating the secure boot process to load malicious firmware or attacking trusted execution environments to break isolation. A critical threat is speculative execution attacks, similar to Spectre. Modern processors guess which instructions to execute next to improve speed. An attacker can trick the processor into speculatively executing code that accesses a secret like a password. Although the result of this wrong guess is ultimately discarded, the action of loading the secret leaves a trace in the shared cache. The attacker then measures cache access times to detect this trace and leak the secret. This has been proven feasible on RISC-V cores. To mitigate this, we must make speculation invisible. Solutions like InvisiSpec work on isolating speculative memory loads in a private buffer. The data is only committed to the shared cache if the speculation was correct. If it was a misprediction, the buffer is simply cleared, leaving no trace for an attacker to find. This is this is a pseudocode of how InvisiSpec would work. And if it is speculative, then well, you add it to the speculative buffer. But otherwise, and the speculation turns out to be a misprediction, went down a path which did not result in anything concrete, then you don't add it back to the cache. The speculative buffer is just flushed. Now let's look at two physical attacks. In a power side channel attack, an adversary measures the CPU's power consumption. Because power usage fluctuates based on the data being processed, these patterns can be analyzed during a cryptographic operation to mathematically extract the secret key. The open nature of RISC-V can make modeling these power characteristics easier for an attacker. Electromagnetic fault injection, or EMFI, is a more direct attack. A precise high-energy EM pulse is aimed at the chip to induce a timing fault or a bit flip. This can cause the processor to skip a password check or corrupt a calculation in a way that reveals sensitive information. To counter power analysis, we can use randomization. Random dynamic frequency scaling constantly and randomly varies the processor's clock speed. This breaks the correlation between power consumption and data processing, obscuring the signal an attacker needs. To counter EMFI, we can enforce control flow integrity or CFI. A hardware component called a trace verifier monitors the sequence of executed instructions in real time. It compares this live trace against a pre-computed secure path. If an EM pulse causes a jump or skip, the deviation is detected, and a fault handler immediately halts the CPU to prevent the attack from succeeding. And this is how it works. I mean, if you have a function, you just update the trace. In the end, you check the trace that you obtained with what you expected. If they don't match, then you just stop the CPU and raise a fault and tell the OS that something fishy is happening. Right. So to ensure system integrity, we start with a hardware root of trust or ROT. This is a fixed, trusted hardware component that anchors the entire system's security. It is often based on a physically unclonable function, PUF, which acts like a unique hardware fingerprint to generate keys without storing them. The ROT enables a secure boot process. On startup, the ROT verifies the bootloader's digital signature. If valid, the system boots. If not, it halts. This creates a chain of trust where each stage verifies the next stage. For runtime protection, we use trusted execution environments or TEs. Frameworks like Sanctum create isolated, secure enclaves within the processor. They use memory encryption and access control to protect sensitive code and data, making them inaccessible even to a compromised operating system. This take it up another level. Okay. So in summary, RISC-V's open and modular design is a powerful driver of innovation, but it simultaneously expands the hardware attack surface. Vulnerabilities like side channels and fault injection are not just theoretical, they're practical threats. Defending against them requires a hardware-software co-design approach, building security in from the ground up. The path forward is clear. The RISC-V community must prioritize the development and adoption of standardized security frameworks. This is especially critical as RISC-V is adopted in sensitive sectors like automotive, finance, and defense. Collaborative open source security research is the key to hardening the entire RISC-V ecosystem. Thank you for your attention. I'm happy to take questions.
Yes, good morning, sir. Yes, good morning, sir. Are you able to listen?
Yeah. Good morning, ma'am.
Yeah, good morning. Sir, I have a very basic question. I've seen that the pseudo code, it is handling the exceptions also, and the architecture wise also it is fault proof. The basic question is, since it is like a conference belonging to ICT for sustainable development, it was a very basic question inquiring how does it relate to it?
Um, it relates to it. I mean, there is a very tight correlation between this. So when I was working for Epic in the US, that it's a medical health record company, the time Spectre and Meltdown came in 2018, if you remember that. I mean, they took the world by surprise, right? So in the town hall meetings, they would call us and say, you optimize the code because the mitigation that they have put in Windows and Linux, like KPTI and a host of other things, are going to reduce the performance of this by 20%. So now either we will have the hospitals buy more computers, and by buying more computers, well, there is wastage, there is electricity, there's all sorts of sustainability issues there. Or maybe we can, put our heads together here and come up with a design right from the ground up, which would be secure without having us to buy more computers, because with these patches, even with these patches, you can get up to 30% performance degradation, right? So that is how it will,
Right.
yeah,
Yeah, got it. So that means computational efficiency is one of the factors, and you're
yes,
relating that way to it.
correct.
Right, right. Thank you so much, sir.
Thank you.
Thank you, sir, for your presentation. Sir, I believe you have one more presentation in this session only
Yes.
for a different paper title. So would you be able to continue with that one right now?
I'll just take a sip of, water and just get started with that. All right.
Yes, sure. If you need some time, we can have another presenter and then you can do it later on. That's all right.
Yeah, I can just do it right now. Just give me one minute.
Okay, sure, sir. Okay.
Let's continue. So that way he'll be free from the presentation for his part also. Let him continue.
Yes, yes, sure.
Thank you very much.
Excuse me, ma'am. My voice is audible now?
Yes, ma'am, your voice is audible, but
Okay.
there is a lot of disturbance in your voice. The background is not clear.
Okay. Okay, ma'am.
Is the new slide deck visible now?
Yes, yes, sir, it is visible.
Okay, thank you very much. So again, I'll be presenting this cash and speculative side channel attacks, same set of authors, two of us from BITS Pilani, and we have a student from KIT. So I also teach at KIT, so it's kind of mixed up that way. All right. So modern processors use a speculative execution. I mean, we talked a little bit of that. So this is more about, an overview of what all more different kinds of speculative attacks that can happen, right? So processors use speculative execution to boost performance. However, these optimizations create security vulnerabilities. So our paper reviews the evolution of these microarchitectural attacks from the initial discovery of Spectre to recent exploits on Apple Silicon. I mean, the new laptops which we get from Apple M1, M2 up to M4. Right? We analyze the attack mechanism, their implications, and the various mitigation strategies across hardware, operating systems, and compilers. The aim is to provide a foundational understanding for designing more secure systems without significant performance loss. At the heart of this issue is a conflict between performance and security. CPUs rely on optimizers like multi-level caching, out-of-order execution, and branch prediction. When they'll predict, they'll think, well, we'll take the branch, and later they'll find, oh, it's correct, that's good. Otherwise, it was a bad prediction, so let's revert everything. So these features, however, create side channel vulnerabilities. The landmark discoveries of Spectre and Meltdown revealed that speculative execution could bypass fundamental security boundaries. The initial response involved software patches that, while necessary, led to performance degradation of up to 30% in some cases, without fully solving the underlying problem. So let's begin with classical cache attacks. The flush and reload attack exploits the time difference between accessing data in the cache versus main memory. It requires the attacker and the victim to share a memory region, such as a library, a shared library. The attacker first flushes a specific memory line from the cache. Now the victim will start running. Well, if it loads it, then the attacker starts to verify that, okay, let me load it again. So fast reload time indicates the victim accessed that address, loading it back into the cache. A slow reload means it was not accessed. I mean, the victim did not bother about, you had removed it, so I don't even care. It's going to be slow. So it was not accessed by the victim. So from this side channel information, the attacker can know something about some secret data somewhere, right? Just the timing difference and the flush behavior. Another classic attack is prime and probe. Unlike flux and reload, this does not require shared memory. The attacker begins by priming the cache, filling specific cache sets with their own data. The victim process then starts to run. It will also need access to memory. So what will it do? That the entire cache is filled up by the attacker's data. So the cache will have to flush something. Okay. So after the victim has completed running, the attacker comes and checks one by one. What data of mine have you flushed? Okay. So now it knows, okay, this set, this index was removed. So from that, it can deduce, oh, okay. If it does it multiple number of times, it can deduce some kind of a secret from the victim. Meltdown was a paradigm shift. It exploits a flaw when CPUs speculatively execute instructions before completing a permission check. For example, The attacker can request a read to a privileged kernel memory address. Even if it is not mapped in the page tables, it can still do it. Although this will eventually cause a fault, the instruction is first executed transiently. Like, let's do it, we will see later. Let's fetch it and keep it in the cache. Later, we will not give it to the attacker, but we will bring it to the cache transiently for some time. So during this brief window, the secret data from the kernel address is loaded into the cache. The attacker then uses a cache timing sites and attack like flush and reload to determine the value of that data. Spectre. Spectre attacks exploit the branch prediction unit of the CPU. An attacker can intentionally mistrain the branch prediction. Like, you can train the branch, it learns from your patterns, so the attacker will mistrain it. So this causes the CPU to speculatively execute code paths that would not normally be taken. Right? The predictor was correct and trained properly. These branches will not be taken. But now the victim will take some weird branch somewhere. For example, an out-of-bounds memory access can be triggered transiently. Although the results of this speculative execution are discarded, the process leaves traces in the cache. Again, they can do any of those previous classical attacks and then figure out what was there. Beyond Spectre and Meltdown, a new class of attacks emerged. Microarchitectural data sampling, or MDS, leaks data from internal CPU buffers. Some variants are called zombie load and cache out. Then there is load value injection, where the attacker injects malicious data into a victim's transient execution, poisoning its speculative operations to leak secrets. Now, this is something that many people would probably identify. If they have done 8086, there is a flags register which shows zero overflow, right? So the attack vectors continue to start using this. Okay. So they measure the timing of conditional branches to infer secrets. This bypasses many cache-based defenses. Concurrently, attacks on Apple Silicon have emerged, such as Spectre LAP, which mistrains the load address predictor, and Flop, which poisons the load value predictor to leak data. The attack surface is constantly expanding. Post-barrier Spectre attacks show that mitigations are incomplete as other predictors remain vulnerable. High-precision branch target injection attacks make Spectre more reliable. Apple's data memory dependent prefetcher has also been exploited to break constant time cryptography. Even GPU data compression has been shown to create a side channel, allowing an attacker to infer screen contents by measuring rendering latency. So whenever there is some kind of a time, so they will see what is taking longer, what is taking shorter, and if they do it millions of times, then they'll figure it out. I'm not saying it is feasible everywhere on your computers, but it does happen. If someone is motivated enough, they'll end up doing it. So these attacks have been adopted to complex environments. The inception attack corrupts branch predictors during transient execution. It's like a dream inside a dream, like the movie. So this is how they do it here too. So Slapstick targets the Linux kernel heap allocator to achieve privilege escalation. Furthermore, these fundamental techniques have been successfully demonstrated in cross-VM, browser-based, and even trusted execution environments like Intel SGX and ARM TrustZone. So now let's briefly talk about some mitigation patterns. The first pattern is isolation and partitioning. The goal is to separate secure domains. Kernel page table isolation separates user and kernel address spaces. So when user code is running, the kernel page tables are not mapped. So the user cannot even try to attempt to access anything from the kernel address space. Hardware partitioning, like Intel's cache allocation technology, dedicates cache regions to specific processes. Each process has its own cache area. So now the attacker won't be able to see or time or do anything with that region. Software-based page coloring achieves a similar goal. In browsers, site isolation runs each website in a separate process to prevent cross-origin data leak. The second mitigation pattern involves controlling speculative execution directly. Speculative fences like LFence acts as barriers to stop speculation. The points you can say, now don't speculate. This is our critical code. Don't speculate. Even if it's a little slow, let it be, but let's be safe. Okay. So CPU vendors release microcode updates to flush internal buffers, mitigating attacks like MDS. At the
Hello.
yeah.
So sorry for the interruption, but can you please get to the conclusion?
Just 20 seconds. So at a compiler level, techniques like red polling replace indirect branches and so on and so forth. And The mitigation pattern, you can randomize and obfuscate, right? You can randomize the address layout. So even if the attacker knows which cache line, they don't know what was there because the address space has been randomized. And you can obfuscate the timer. You can reduce the precision of the timer so they cannot time what is taking quicker, what is taking slower. It is difficult for attackers to do that. So let me conclude. In conclusion, the drive for performance has created a persistent arms race in CPU security. As we patch one vulnerability, new attack vectors emerge from other hardware optimizations. The trade-off between security and performance remains the central challenge. The path forward requires a shift from reactive patches to proactive security-first architectural design, using formal methods to verify hardware and promoting close collaboration between hardware, operating system, and software developers will be essential to building truly secure and high performance systems. Thank you. Any questions, please?
Just a small question, sir, that you had presented zero codes in both of your presentations.
Huh?
Have you implemented it somewhere on some platform?
Yeah, I mean, this is a review paper. These attacks have been implemented by the people who found this attack. So there are separate papers for all of this. And I myself, for my own PhD, I have been also playing around with this attacks, trying to replicate it to my Raspberry Pi here and there. So yeah, so some of them won't work anymore because there are mitigations already. Some of them will work with a lot of effort. But yeah, to answer your question, yeah, we do it.
Yeah, okay. Because since the results were not highlighted, that was the question. Since it's a review paper, that's okay. Thank you.
Okay. Thank you. Thank you, ma'am.
Thank you, sir, for your presentation. Now we will proceed with the next presenter. So the next presenter is Murari Nallamali from Amrita Vishwa Vidyapeetham, India. And the paper title is AI-driven load balancer for cloud computing environments. Sir, I request you to please proceed with your presentation.
Hello, am I audible?
Yes, sir.
Okay, I'll be sharing my screen.
Sure. Sir, after 8 minutes, I will be raising a reminder so that we can get to the Q&A session.
Okay. Is the slide visible?
Yes, sir.
Okay. Good morning, everyone. I am Murari, and this is a simulation work which we have done on the importance of an AI-driven load balancer in cloud computing environments. So this work is done by me and my other classmates, Nitin, Dore Sai Charan, Vijay, and our lecturer, Dr. Beena. This is done at Amrita Vishwavidyapeetham, Bangalore. So at first, the importance of an AI-driven load balancer. To know that, we need to understand what's a load balancer. So the load balancer uh, is a function which allocates work to different nodes in a cloud environment. So in the current technology, cloud environments are broadly used for various applications such as streaming platforms and data processing networks. So the traditional load balancer uses round robin or weighted round robin to dynamically allocate the workloads across the nodes. So what we are proposing is the use of an AI-driven load balancer which works on a reinforcement learning based algorithm. So what we've done is we've simulated a cluster of nodes where we've declared a few nodes and got their matrices dynamically, which are then sent to the model. To do this, we've referred few papers which are review papers of several algorithms that can be used on a cloud platform to dynamically allocate workloads. So there are several kinds of algorithms which can be used, which were mathematical and computational. So in the machine learning based algorithms, we've chose the DDPG algorithm, which is a type of reinforcement learning algorithm which has two major parts, which is actor and a critic. So we've referred papers uh, which explain how the DDPG algorithm works and how it can be utilized in a resource allocation way. The proposed system is where the load balancer is the load balancer is trained with a DDPG model, which has two parts, an actor part and a critic part. Actor is which gets the work request from the network and allocates it to the node based on its matrices like the CPU usage, the time, the workloads of each node, and allocates it accordingly to the node which is most suitable. And after it allocates it to a node, the critic part gets the critic part rates the allocation based on how it is distributed. Like if there are five nodes in a cluster, and our actor allocates the workload to the node which is already working to its full and not to a node which is idle, then then the critic gives a negative score to the actor to indicate that what it did is not the ideal solution in the current case. In such way, after several hundred iterations, the actor learns the best way in which it can allocate works in the cluster. So, the proposed solution is just a simulation of how a AI-based load balancer could work in a dynamic cloud environment. So from the simulation, what we've learned is that the AI-based load balancer is slightly efficient than a weighted round-robin load balancer or a round-robin load balancer, where it saved the energy consumed by the nodes uh, by approximately 10%. And as I mentioned, this is just a simulation we've done to study the use of load balancers. This can be changing when it is actually implemented in an environment where several hundred nodes are actively working to meet the requirements. So, to conclude this, I would say that instead of a traditional round robin or a weighted round robin load balancer, usage of an machine learning based load balancer could efficiently reduce the energy consumed by the cluster and also the wait times of the requests. Thank you. Any questions?
Thank you, sir, for your presentation. Are there any questions? We can proceed with the next presenter
Yeah,
then.
yeah, just 1 second. Actually, there is no question on it. I was just listening to it, so it's more of theoretical. Results couldn't again be found, but that's okay from a student point of view.
Yes, ma'am. So, thank you.
Thank you, sir. So the next presenter we have here today is Ankit Agarwal from PES University, India. And
Yeah,
the
good
paper
morning.
title is Classification of SSVEP Brain-Computer Interface using CCA CWT CNN. Sir, I request you to please start with your presentation. After 8 minutes, I
Yeah,
will be raising a reminder.
sure.
You can share your screen now.
Yeah, is the screen visible?
Yes,
Yeah. So I'll start.
yes, sir.
Yeah. So good morning, everyone. I am Ankit Agarwal, and I'll be presenting a research paper which is titled "Classification of SSVP Brain-Computer Interface Using CCA, CWT, and CNN." This is a research work carried along with Ashlesh Kumar, Ankur Pandey, and Dhanushdi, along with our professor, who was also our mentor during the research project, Professor Shwetaji. So let's start with understanding what's BCI. So BCI is a brain-computer interface is a system that captures brain signals, interprets them, and translates them into commands for external devices. There are several type of brain waves, but we will be focusing on a specific type of wave, which is called as SSVP. So these are the like the main four parts of the brain, and the waves which we'll be focusing on are generated by the occipital lobe of the brain. So these are the type of brain waves which are generated by our brain. So this is the classification of BCI. There are two methods of doing study on BCI, which involves invasive and non-invasive, and there are several other branches to this thing, and we will be focusing on non-invasive method. So coming to the SSVP based BCI. So SSVP stands for steady state visually evoked potential. These are the signals generated in the occipital lobe when a person focuses on a flickering visual stimulus of a particular frequency. So the main advantages of using the SSVP signals include it has an easy configuration, it has a high information transfer rate, and it has less user training. So this is to demonstrate how the stimulus looks. And this is the 1020 standard placement of electrodes, which helps in the non-invasive capturing of the signals. So after conducting a thorough literature review, like these are the literature gaps or challenges which we found. Like past studies focused mainly on traditional methods like CCA and FBCCA, which provided decent accuracy but struggled with generalization. Deep learning models have shown promise, but a few studies explored combination with classical methods. Hence, we aim to integrate the strengths of both. Coming to our proposed methodology, our pipeline involves obtaining the data set from the pre-Tisigna lab, and then pre-processing the data set using fast ICA, and feature extraction is done via CCA, FPCCA, and CWT, and the classification using CNN, which includes deep convolutional net, shallow convolutional net, and EEG net. All the code was implemented in Python using frameworks like MNE, Keras, Skikit, and Matplotlib, and the dataset is obtained from the benchmark dataset. So these are the dataset details. And the dataset, we just reshaped the dimensions into 4D, which had these 64, 1500, 40, and 6 as its 4 dimensions. So coming to the technologies part, we used fast ICA. Fast ICA stands for Independent Component Analysis. This is a statistical method which is used to separate mixed signals into independent sources. It is applied to pre-process EEG data by isolating relevant neural components and reducing noise or artifacts. And then coming to the feature extraction methods, we first use CCA, which stands for Canonical Correlation Analysis. It is a multivariate statistical method that identifies correlation between two sets of variables. It is commonly used to extract and classify frequency-specific features by matching EEG signals with predefined reference templates. And the next is FBCCA. So FBCCA stands for a filter bank canonical correlation analysis. It is again used for feature extraction. It is an advanced version of CCA. And the last methodology is CWT, where we had wavelets created of a particular window size, and the features were extracted. Coming to the classification part, we used three deep learning models, which were EEG-net, deep convolutional net, and shallow convolutional net. So this was the CNN model, all the layers which we had, and the parameters. So coming to the result and analysis, we kept the pre-processing part as constant. We kept it constant. Like we only used fast ICA, and we had a few tinkering around feature extraction and classification techniques. So coming to the first thing, where we used FBCCA as both the feature extraction and classification techniques, the classification accuracy which we got was 89.80. As we can see, the highest classification accuracy which we got was when we used deep convolutional net as the classification technique. So the classification accuracy which we got was around almost 92%. So this is a part of application where this method could help motor impaired persons. We just map the flickering frequencies to a task label, which are the basic tasks which a motor impaired person would require, and this is the actual this is the result. Like the result was accurate. So concluding, so advanced CNN models like deep convolutional net, shallow convolutional net, and EEG net demonstrate high accuracy for SSVEP classification, and pre-processing techniques and feature extraction methods such as FPCCA, CCA, and CWT significantly enhance the classification reliability. Robust validation methods like K-fold cross-validation are crucial for generalizing and optimizing. So future works which we will be focusing on are the test methodologies like FPCC and CC and CNN models in real-time SSVP based. And we also aim in enhancing the robustness by integrating multimodal features and also use AI, advanced AI technologies like GANs and VAs for synthetic data augmentation. So these are the reference papers which we went through. So, questions?
You have beautifully explained the results. Did you compare your results with any of your referenced works which you have taken up, like 24, the latest one you have taken up? So 91% you have stated. Did you compare your results with the others who have done the taken that similar data set and approach?
Yeah, the other papers have taken the similar data set, but the proposed methodology by them was completely different. Their accuracy was comparatively less when compared to deep convolutional net.
So that implies that your approach is entirely different from anybody who has taken it previously?
No, not entirely different. Only one of the methods. So there are three methods, mainly three methods of doing pre-processing, feature extraction, and classification techniques. We only changed the classification technique part of it
Okay, thank you.
and used a deep learning model called as deep convolutional net.
Yeah, right. Okay.
So I have a question. Can I ask?
Yeah, sure.
Do you have any data on false positive rates and false negative rates? Because if it's 91%, and since it's going to be used in medical scenarios, it is
Yeah.
also important to know what are the false positive and false negative rates.
That was comparatively very less. Like I
Hmm.
don't have it right now with me.
All right.
Okay, thank you, sir. Now we will proceed to the next presenter.
Yeah, thank you.
So the next presenter is Radhika Kulkarni from Vishwakarma Institute of Technology, India. And the paper title is Legal Case Search and AI-powered legal search engine. I request Radhika ma'am to please start with your presentation.
Yes, sure, ma'am. Thanks for giving this opportunity. Just give a minute. I'll share my screen. Is it video? Is it visible, ma'am?
Yes, ma'am, it is visible. You can start with your presentation.
Yes, just a minute. Yes. Good morning, one and all. So I'm Dr. Radhika Kulkarni, working as an associate professor in Vishwakarma Institute of Technology, Pune, Maharashtra. So we are going to present on behalf of my team. I'm presenting legal case search and AI-powered legal search engine. So agenda of today's presentation will be introduction, motivation, literature review, problem statement, proposed methodology, results, conclusion, and future scope. And then it will end with references. So in introduction, I just wanted to say that we are the largest democracy in the world, and which is having three broad pillars of our Indian democracy is law. So legislatures who make laws, the executives who enforce laws, and the judiciary that interprets laws. So in Indian judiciary system, the massive reliance is on previously established legal decisions, that is called as legal precedents, which will help our lawyers to understand how laws have been applied in similar cases, ensuring that legal arguments align with established interpretation and judicial intent. So the advancements in AI and natural language processing can be leveraged in this domain as well for the legal case search, which will help the lawyers to understand or to search or retrieve the previous decisions or legal precedents easily. So the motivation behind it, government of India has taken many efforts to put all this data on digitized platform. So there are websites like indiacode.nic.in, judice.nic.in, where we can get different results or different judgments of different legal cases. However, these sites are having legal information which is very difficult to navigate, overwhelming users with thousands of sections, then acts, cases, and it is filled with some complex legal jargon. So it is challenging for any common people to understand it. So considering these challenges, we have noted the major challenges as high volume of legal documents, then complex language and structure, difficulty in identifying contextually relevant cases, time sensitivity, because if I want to spend time in searching the document to get the correct document, by the time I'll lag behind the time. So time is very sensitive in case of any legal decisions. So it will be helpful to lawyers, it will be helpful to judges, it will be helpful to any layman, so or any victim. Even so, challenges in legal research for non-experts. That is, these are the major challenges. So this motivated us to go for an AI-powered legal search engine. So we have gone through different literature reviews. Many papers are working on some chatbots. Even we have studied different types of work, some vectorization, word embedding, how LLMs are working, and how some use cases of law has been implemented. Means for Canadian government, they have implemented. Even in India, they have implemented a little bit using the word to vec and that type of cases. So by studying this, we have identified the research gap that there is limited case diversity, then limited integration of advanced AI techniques, then focus on narrow legal domains and challenges in user experience and absence of comprehensive legal data sets. So in this case, for this research work, we have considered the different legal documents, different legal judgments. We have taken the at the max 50 pages judgment is correctly comprehended through our system, and it is giving the answer just like the human language. It is giving the natural language processing we are applying, and the chatbots using LLM models, we are developing the solutions which is user friendly. So the problem statement of our research is to develop the chatbot to simplify the access to legal information and guidance, empowering individuals to navigate their legal rights and take actions effectively. So this is AI-based legal search engine, which offers an intelligent, context-driven approach to legal case search and retrieval. It aims to innovate within the legal search field, creating user-centric tool that enhances productivity, decision-making by providing precise, relevant legal case references. So the proposed methodology consists of two phases. One is the database generation and another one is the data usage. So as I mentioned, we have referred to different government sites, legal sites, and from those sites we have downloaded different judgments. It could be in CSV format. Some legal metadata is maintained, that which case, then what is the date, who was the what was the panel and bar members. So all those that type of data is already having in CSV file. Similarly, there are some text documents or PDF documents. We have collected all that type of data. Then we summarized that data and we applied the chunking on that data, and we created the vector embeddings for every chunk. And then we have stored all this vector database as an input and these embeddings as an input for our LLM based AI search engine. So that is our first phase of database generation. Then whenever user fires a query, so that is a usage of a data. So user query flow is depicted in this slide. So you can see that whenever user fires a query, so the query is processed at the backend. Again, the query is also transformed into vector representation. Then using the vector database, which we have already created, we are going to compare with the query and the vector database, and we are going to find out the cosine similarity for that. And based on that, we are going to find out the top 5 searches. Then we are going to prepare the context for the LLM. So based on those top 5 searches, we are going to search, we are going to send the context to the LLM, and we are going to generate the human-like responses. And then the responses will be returned to the user. So if you can see, this is our class diagram. So user is going to fire a query. It will be fired through one web application. The query is forwarded to the web server, where the query is, again, as I mentioned in the previous slide, it is divided into chunks, and then vector database is created. This vector database is compared with the available material or available database, which we have already prepared. And then accordingly, the context is transferred to the LLM. LLM will find out the similar results or summarize the whatever are the judgments, or it will also give the which type of similar case or such type of queries we have fired, and then it will respond to the user. Then for result analysis, we have considered 2 metrics, because though we are in the era of Gen AI, human intervention is very important, because legal documents and all such cases are very sensitive. So there should not be any misinterpretation. For that purpose, human intervention or expert opinion is at most important. So we have evaluated our system in both ways. One is using our traditional performance metrics. These are based on our empirical analysis. That is, we have used accuracy, precision, recall, F1 square, and perplexity score. Particularly, perplexity score is used for the NLP based systems, for such models where we are going to check that how well my language model can predict the sequence of words. So for that purpose, we have used a perplexity score, and accuracy, precision, recall, F1 are having their traditional performance. So, and another approach that we have followed is human feedback. So we have used different models. So 5 models, large language models we have used for our experimentation and comparative study. So we have used Llama 3 with 8 billion parameters, Llama 3 with 70 billion parameters, then Gamma 7 billion parameters, Gamma 9 billion parameters, and Mistral 8 by 7 billion parameters. So in this case, if you can observe that the Llama 70 billion parameters, the model which is having more features, means more parameters, that model has given the better accuracy as well as even precision, recall, and F1 score. And even in perplexity, you can find out lower is the perplexity, better is the performance of the model. Means it is easily predicting the next sequence in your n-gram data. So here you can observe that the perplexity score for Llama 370 billion is low as compared to other models. So it is
Ma'am,
giving us better solution. Yes, yes, it is.
ma'am, okay,
Yes, yes, it is last, just 2
okay.
seconds. Yes. So it shows that Llama 70B is performing better. Again, we have taken the human feedback as well for all 5 models. So whatever answers we are getting after firing the queries, we have compared it. So here again, if you're going to see that Llama 8 billion parameter is giving just answer, but many times it is hallucinate. Then Llama 70B, it gives best overall performance, and it will also understand or reject non-legal questions. So it does not hallucinate. 7B, Gemma is it does not provide good description. It just gives stakeholders or hallucinates sometimes. Whereas 9B, Gemma is giving very short summary. And if more than one similar case is present, then it gives only detail of one. It is not considering all other listings. And Mizral, it is having high hallucination, so it does not provide good summary. So that is our interpretation through the expert's opinion. So based on that, we concluded that Llama 70B is a model which is suitable for our use case. Obviously, for one solution cannot fit for every use case. So for our use case, we are claiming that Llama 370B is doing well. And obviously, as more number of parameters in the model, then it will give the better results, and as well as the better data format and context will give the better results. So in conclusion, I would like to say that using this legal research, using this system, it will revolutionize legal research because it will save the time, it will give the accurate result, it will give the automated retrieval and summarization. And with this open source foundation scalable design, the platform is poised to democratize access to legal knowledge, fostering information decision making. And in future enhancement, we are thinking of having multilingual capabilities, promising the expanding its utility further. So it will be evolving legal landscape. So these are my references. Thank you so much. If any questions?
Thank you, Dr. Radhika.
Yes.
The results are all good, but I was just wondering, when you have taken the input as vector embeddings and the databases, my one of my student was working on a similar kind of project, but with BERT and TF-IDF. So, how do you compare? Would these databases and language formats be better than the vector embeddings? Uh, because
See, uh,
BERT seems to
only
be a better one.
Yeah. I would like to give this answer. So only TF-IDF will not see TF-IDF while creating the vector embeddings. There are many methodologies. So we even TF-IDF could be one of the methodology which will contribute to develop the vector embeddings. So we have used word to vector embeddings and then we have created it. We tried many of them, but finally we got better results with this. So we are proceeding with these methodologies.
Okay, better results in the sense, you're saying
Accuracy
that,
means whenever
okay.
see we are having when legal documents are there, na context matters a lot. Even the semantic meaning matters a lot. So only just a sequence of words or having the importance to that word, it doesn't give me correct answer. So if we want a summarized proper document with that contents, means I'm going to give the prompt like I'm having this type of case or this type of a pattern. Could you please suggest me different cases or different judgments related to this one? So here in this case, exact term is not getting matched. So sequence or context is getting matched. So word to wake or such type of models will help me to have the sequence of words and it will predict. That's why I have used perplexity score over there. So whether it is predicting what could be the next and that particular sequence to vector model, and that's why this type of word to vector embeddings are helpful for giving me better results.
Yeah, got it. Got the point. Thank you so
Thank you.
much, ma'am.
Thank you
Thank
so much.
you.
Thank you. Thank you. Thanks for giving this opportunity and thank you to ICT4SD, all organizers for arranging this platform for us. Thank you so much.
Thank you, ma'am. Now we will proceed to the next presentation. So the next presenter is Praveen MP from Amrita Vishwa Vidyapeetham, India. The paper title is Sentiment Analysis on Consumer Opinion Regarding Electric Bikes in India, a Machine Learning Approach. I request Praveen sir to please start with your presentation.
Audible.
Sir, after 8 minutes, I will be raising a gentle reminder.
Okay, am I audible?
Yes, sir.
Okay, I will share it. So you can see, right?
Yes.
Uh, thank you for giving this opportunity. So my topic is sentimental analysis on consumer opinion regarding electric bikes in India, a machine learning approach. So my co-authors are Prajwal SP, Danya Raji, and myself, Praveen MP. Um, so in let's get into the topic. So India electric vehicle market is growing rapidly and major players like Royal Enfield, Ola, Hero MotoCorp is actively developing and launching electric bikes. This clearly shows that electric bikes are going to be the huge segment in future. And when we look into the background of the study, we can see that electric vehicle play a major role in reducing carbon emission and enhancing the energy efficiency in India. This transition is happening fast due to the rising fuel prices, economic concern, and a strong government support through a scheme like F8. And India's EV goals and SDGs. India's targeting 30% of the EV penetration by 2030, and this support the several sustainable goals like SDG 7 for clean energy, SDG 11 for sustainable cities, and SDG 13 for a climate action. And these are some recent studies which is out of the in the market. So as per the JMK research, over 14.13 million EV are sold recently, and more than 55% were electric two-wheelers, and sales have grown significantly, especially in states like UP and Maharashtra. Major players outside, Ola, Electric, Ather, TVS, and Hero MotoCorp, etc. So these are some newses, out of the market, which clearly shows that the electric two-wheelers adoption rising 13% and share expected by 2026 to 2027. And, in two-wheeler market is currently 315 billion right now. And, but in coming 2029, it will be reached to 347 billion market. So it is going to be the highest market in the world. And Royal Enfield is, planning to launch an EV bike in this market. So let's get into the part. So we have taken us. I've attached a link there. I hope you can see that, right? It's Excel sheet. So I've taken 7 to 8 existing research out there. And however, when we look into the existing research, we notice something important. Just most studies focusing on electric cars or scooters, but there are very little research, specifically targeting to the consumer sentiment about, the electric market. Electric bikes. Um, so the research gap, which So the research gap which we found was like most studies focus on electric cars and scooter less than electric bikes, and few studies use a sentimental analysis to evaluate the consumer opinion. And this study bridged, the gap by using data-driven sentiment analysis. And the research questions are: what are the prevailing consumer sentiments toward electric bikes, and what key factors influence, the consumer perception of electric bikes, and how accurately can machine learning models predict sentiment, from user reviews. And the methodology which we used was a quantitative, and the secondary data is from reviews. The reviews, in the sense, we take the reviews from forums such as Bike Wale, Bike Deco, Bicycling, Sick Wheels, and Electric Bikes reviews. We have taken the reviews from there, and we use web scraping tool such as Beautiful Soup, Celium, etc. And the unit of sampling were 3,395, and data analysis tools are Veda, text blobs, etc. And we have done a multiple data analysis tools like Navibytes, XPM, logistic regressions. And these are the process which we have done in sentiment analysis, which we have collected the data, and we reprocess the data, and we feature the selection and future vector constructions. And next process was the sentimental identification and classification by using learned classifiers. And next was analysis and evaluation of models by accuracy, precision, and recall and F measures. So that is the complete process of sentiment analysis which we have done so far. And when we have done the sentiment analysis using text blob and Veda. So basically, the text blob is nothing but it's a free open source library in the Python for pre-processing textual data. So when we have checked the data of that, which we could found that 71.25 percentage is positive review when it's in the text block sentiment distribution. And when we are checking in Veda sentiment distribution, we could find that 52.5 percentage is a positive, and 19.1 is a neutral, which we could found. And comparing in this though, the text block sentiment data shows a more accuracy, which is 71.2 percentage shows positive. And we have done a word cloud analysis basically. And we could in the group of 3,395 reviews, we have done a word cloud analysis, and we could found that most of the people are concerned about the comfortable and battery charge. These are the most repeated words which we could found at this the complete study. And another was a thematic analysis also has been done in this. So in this thematic analysis, we could found that these are the the reviews. The themes which people are more focusing on, as I said earlier: the performance, speed, battery life, charging, cost, affordability, and environmental impact. These are the things which people are looking into and people are more concerned about. And we have also done the technology acceptance model, which we can call it as TAM model. So for we can see that we have taken adoption decision in this, and in that we have found the multiple factors to accept the adoption decision was that when it comes to the external factors, the people are looking into the government incentive and charging infra. When it comes to the perceived usefulness, people are looking into the cost savings, instant torque, and eco benefits. And when we are looking into the attitude towards use, it is based on sustainability and reliability. And it's when we are looking into the perceived ease of use, people are looking at charging infrastructure and battery range, concern, distance. And when it comes to behavioral intention, people are looking into the brand test and after sales support. So this is what the TAM model is. Then and next was when we are getting into the overview of sentiment analysis. The we have done a Navy base. For Navy base, it is for the explanation. What is Navy base is the fast and efficient when it's with a small data set, the work well and its importance in the independent. Example, the symbol spam detection, etc. So the limitations are assume word are independent, which is not always true, less accurate, and sentiment depends on the context. Example, if the amazing appear 80% in the time, the positive reviews Navy base will be classify any review with amazing as positive. So when it comes to the logistic regression, it is best for interpretable results can see which word influence sentiments and works well for the binary classification, which is positive versus negative. The limitation is not ideal for the complex test relationship and struggle with a highly imbalanced data. If there are too many positive reviews, it may predict everything as positive. Example, if the excellent appears mostly in the positive review, the logistic regression will assign higher weight to excellent when it's predicting to this the particular sentiment. Next is the SVM. So when the text data has clear separation between the sentiments, the works well for high dimensional text data like the word vector. And limitations are does not understand the context of word, only the presence. And the slower for the large data set because it will find the best and boundary. And example, if the great appears often positive reviews, the terrible negative ones will be SCM will be one into the separate this. So these are the results which we found through all the models, and we have done all the the models all the results using the Python. So these are the results, and we could find that Navy base is
Hello.
85.6%. Hello.
So sorry for the interruption, but we are past the presentation time. Can we please get to the conclusion?
Sure. um, so these are the findings and recommendations which we could found. And when it comes to the conclusion, our study shows that while consumer having a generally positive attitude towards the electric bike, appreciating their eco-friendliness and the low running cost, and this there are still major concern. The key issues include the battery range, lack of charging stations, and a high upfront cost and poor after-sales service. And these factors often discourage the buyers despite to the government initiatives. And our machine learning language, especially SPM, prove that effectiveness is analyzing the sentimental, helping us better understand of the consumer opinion. To boost adoption of manufacturers and policymakers must focus on improving the infrastructure, offering affordable options and building trust through the better but removing these barriers is I'm audible.
Hello. Thank
Yeah,
you,
yeah,
sir, for your presentation.
yeah.
Are there any questions, or should
Uh,
I proceed further?
no, Siddhi, there is one question from Mr. Praveen.
Yeah, yeah,
Uh, Hello. Yeah,
yeah,
am I
ma'am.
audible?
Yeah, ma'am.
Yeah, okay.
Yes, ma'am.
When you took the initial data set in the form of questionnaires for customer reviews, and
Ma'am,
that too,
basically,
it was a
we have
secondary
never
data.
took the questionnaire for the data set, ma'am. Actually, we
How
have
did you
taken
take
reviews.
the data, customer
So
reviews?
no, customer reviews from the online platform, online forums, ma'am. Actually, we have multiple online forums such as Bikewala, Bike Deco, Sig Wheels is available in the
Yeah,
market.
that is right. See, analysis have been done properly. But
Yeah.
what I think that did you see the bias? I mean, how did you make the data set results reliable? when it was from the online platforms and they could have been biased. I mean, that's a major problem over here.
Yeah, yeah, ma'am. But we have taken multiple brands, there
But
are
they,
lot.
I still believe they may be paid or they may be biased.
Ah, there is a chance,
That
ma'am.
affects the
Yeah,
results.
yeah, ma'am.
Okay. Yeah, thank you.
Yeah, thank you, ma'am.
So the next presenter is Akshay Sena from Nitya Meenakshi Institute of Technology, India, and the paper title is Student Performance Predictor. I request Akshay sir to start with your presentation.
Hi.
After 8 minutes.
Yeah. Am I audible?
Yes.
Okay. Um,
Yes,
yeah.
sir, your screen is visible. You can start with your presentation.
Yeah. Good morning, esteemed reviewer, professors, and delegates. I am Akshay Sinha, presenting alongside my team members, Chirag KM, Pranjal Krishnagupta, and Rahul Singh Rajput from the Department of Information Science and Engineering. Today, I am here to present our paper titled Student Performance Predictor. This project was guided by our mentor, Mrs. Vani ES, Assistant Professor at our department. So today we will be going through the contents like introduction, literature review, problem statement, objective, framework methodology, system design, implementation, and references. So for the introduction, the global shift towards data-driven decisions making has reached every sector, including education. Our project aims to predict student academic performance using machine learning, allowing early identification of struggling students and enabling targeted interventions. This directly aligns with the SDG Goal 4, which is quality education. So the problem statement for this is to determine overall student performance effectively using machine learning techniques. The current evaluation systems is most in most educational institutes are reactive. That are they assess students after performance drops. Our problem statement was simple yet powerful. How can we effectively predict a student academic outcome in advance using measurable factors? So this is the literature review. And before explaining the literature review, I would like to explain the data set. So to develop our model, we used a real-world data set that contains 32 independent attributes and one target label, which is basically whether the student will pass or fail. These attributes span across demographic factors, uh, family backgrounds, academic history, behavior, and lifestyle choices. Uh, so for demographic, you can consider age, gender, parental info. Then you have academics like school support failures, study time, behavioral, which can include alcohol consumption, social activity, family relationship qualities. Then uh, and the target variable is uh, whether the student will will pass or fail. So for the literature review, these are the few papers that we went through. And for to give a summary, what exactly we went through is basically we examined our prior research focusing on subject performance prediction, while many studies applied traditional classifiers like SVM, KNN, and decision trees. So most of them lacked subject-specific insights, behavioral analysis, adaptability to real-world classroom dynamics. Then the gaps. So the gaps our project addresses includes the absence of multifactorial prediction models in current literature, limited use of behavioral and psychological data alongside academic factors, lack of personalization and real-time adaptability in prediction systems. Then the objectives, our key objectives for feature selection, model accuracy, practical evaluation. So feature selection we have to identify the most impactful attributes from the factors that are present there to reduce noise and improve accuracy. Then we have model accuracy, use data augmentation and pre-processing to increase prediction reliability. Then we have practical evaluation, which validate the model against real-world student data using standard performance metrics. Then the framework includes simple yet effective data collection, feature engineering, first data collection, then data pre-processing, then feature engineering, model training, and then model evaluation. So many models were trained on the data, and the models which were evaluated to be the highest performing were selected and then were used like an ensemble model. And I created a pickle file out of that and used in my Python project. So this is the system design. So it to basically, for example, if there's a pen, so the teachers can directly hello. So is my voice audible?
Yes, sir, your voice is audible.
Okay, okay. Yeah. So so the teachers can directly tell the parents based on the predictive model that whether the students will perform based on the co-factors, environmental factors, as well as their academic performance of the previous terms. Then we have this system design where we have the data set. We have done the data pre-processing, and then we have trained all these models, and the models which had the most accurate results and less overfitting were selected. And then we created a pickle file to use that model, and then we have simply integrated into the front end, which I have used Streamlit, which is a Python library. And also based on the results, we are also giving suggestions that on what things that student needs to improve. So here are my implementations screenshots. So these are the different factors that can be filled in a form like sheet, and then based on that there will be a prediction of like risk of failing or passing, how much confidence is there that the student will pass or fail, and based on that suggestions will also be given. So here you can see that the student is expected to study more, which is suggested in the output. And here is the references which I have taken. Thank you. Any questions?
No questions.
Okay. Okay. Thank you.
Thank you, sir, for your presentation. Now we'll proceed to the next presenter. So the next presenter is Parmal Smith Dharmesh Kumar from Vishwakarma Government Engineering College, India. And the paper title is Synergizing Fire Detection and Emergency Response, a Multi-Layered Safety System for Residential Communities. Sir, I request you to please start with your presentation.
Am I audible, ma'am?
Yes, sir, you are audible.
Okay, let me share the screen for.
Yes.
Is screen visible, ma'am?
Yes, sir, your screen is visible. You can start.
Okay. Okay. Good morning to all the respected researchers, professors, and all the fellow inventors. Let me begin with a question here. What if your fire alarm could not only detect a fire, but also take action before you even realize there is a threat. That exactly my project is about. Today, I will be presenting our work title, Synergizing Fire Detection and Emergency Response, a multi-layer safety system. A solution that redefines how we think about fire safety using IoT, automation, and real-time communication. Before we talk about the solution, let us understand the problem. Traditional fire alarms, they just beep, that's it. No call, no notification, no coordination. They just rely on human to act. And in fire, seconds can mean a lot. They are just isolated system, often outdated and lack centralized monitoring. So we ask ourselves why we are still depending on humans when machine can act faster. It's what inspired the development of a smarter and good framework. Our aim was clear to build a system that's fast, automated, and intelligent. What we wanted to do is to detect the hazard earlier, send alert instantly, and coordinate between rooms and buildings, and to call for help without anyone touching a phone. So that makes our product scalable and future ready. And IoT powered sensor integrated framework that act the movement when it is active. No delay, no confusion, just rapid automated response. This system handles everything from detection to deployment to escalate in all real time. Here how it works. It sends fire or smoke using reliable sensors. It processes the data via an Arduino microcontroller. It alerts the residents and nearby unit through buzzer, RF signals, and GSM codes. And then it escalates the situation automatically by informing authorities without human intervention. It like your house becomes smart enough to call for help and guide evacuation, sorry, on its own. And what if there is a power cut during a fire? We have also handled that too. DSC, our project runs on a regulated 12-volt power supply with battery backups. So even during a blackout, it does not stop protecting, and and in the future we are adding solar integration to make it even more disaster proof. At the at the heart of the system is the Arduino Uno managing the everything in real time. We use two key sensors like MQ2 for detecting smoke and gases, LM393 flame sensor for detecting fire instantly. Plus our adaptive threshold algorithm makes it to react only to real threats, not to the steep from your bathroom. Further, the GSM calling system. Now, imagine this: fire breaks out, and even before you smell smoke, your home has already detected the fire and sent a discrete signal to dial the fire brigade. That's the power of GSM calling module, completely automatic and always ready. RF-based communication, but here we have RF-based communication. We use 433 megahertz RF module to send fast wireless and alert from the home unit to security cabin. It's like a walkie-talkie system for emergencies, no internet required, no delay. Then after our alerting is not just fast, it is a layered system. Local buzzer just happened in 0.5 seconds. RF alert to building in just 2 seconds, and GSM calling to authorities in just 5 seconds. Within 5 seconds of fire, the system has alerted people, security, and emergency responders too. That's magic just happened here. The home unit senses the fire, send a RF signal to RF signal and call for help. The security cabin receives the RF signal, sounds and turn around and makes a second emergency call, creating double assurance. No, it's not one node; it's a connected network. This is a complete cycle that first detects, processes, then signal, then escalate, and then notify in just one. And all this happens faster than a person can unlock their phone. We did not just design it, we had also tested it in a fire lab through a thick wall in an open airfield and during GSM network. And it performed exactly how we built it, fast, reliable, and in a real time. Here are the numbers. Fire detection in 0.8 second, RF range up to 25 meters in indoor and 35 meters in outdoor. GSM all triggers in under 5 seconds. They aren't just benchmarks, they are proof that a better system is possible. Comparison with a traditional alarm system, it's 95% faster response with 90% better coordination and 85% more automation with 80% higher scalability. In short, it's not a upgrade. The limitations. We are aware no system is like perfect, but our RF range can improve. We are testing Wi-Fi modules too in this project. With adding, we are also trying to add solar powers and making our module design will fix that. AI-based detection can also even smarter can also add a smarter alert system in this.
Hello. So sorry
Yes,
for the
ma'am.
interruption. Can we get to the conclusion part?
Okay, ma'am. Okay. To conclude this, we believe that fire safety shouldn't start with panic. It should start with precision and with system like DSC. We are making that possible. Uh, Thank you so much for your time. Uh, is there any questions?
Thank you, sir, for your presentation. I'll wait if there are any questions, or we can proceed further.
No questions, Siddhi. I was out of the network, but listen to the presentation. Thank you.
Okay. Thank you, ma'am. Now we'll go on to
Thank
the
you.
next presenter. So the next presenter is Samyukta D from Amrita Vishwa Vidyapeetham, India. And the paper title is The Impact of Financial Literacy on Thrift Behaviors, a study among college students. Ma'am, you can start with your presentation.
Yeah, am I audible?
Yes, ma'am.
Let me just share my screen.
Yes.
Oh, okay, so I'm Samyukta and I'll be presenting the paper ID 46, that is the impact of financial literacy on thrift behaviors. And the authors are Chandratara PT, Gauri Girish, and our the guidance was given by Dr. Rojalin, and myself Samyukta D. And I'm from Amrita School of Business, Cochin. So just to give a quick introduction on my paper, I'll just tell you, I'll just give you a background in this. Like we all know, financial literacy, it's like very important for building healthy financial habits, and to also to have a sustainable financial independence in the future. And one of the key factors that affected the financial literacy, or that affects the financial literacy, is thrift behavior, which shapes how individuals manage their money, like including spending and saving. So this paper, it examines four dimensions of thrift behaviors. One is careful thrift, and the other is spending thrift, and saving thrift, and lifestyle thrift. So we're gonna see these thrift and their impact on the financial literacy among the college students. So I have given a quick definition on what these thrifts are. So careful thrift, it involves planned financial decision making. So it tells you how careful you are before making a financial decision. Like, are you aware about it, or like, are you conscious on how you're gonna spend this money or how you're gonna save this money? That is careful thrift. And spending thrift refers to impulsive purchasing behavior. It's nothing but we don't think twice, just spend it. Like, you see something and you buy it, and you're not sure if this is going to help you in long term, or if you really need this and how it's going to benefit you. So the third one is saving thrift. It prioritizes on savings for long term future security. So in this thrift, we primarily focus on our long term benefit and long term goals. And the fourth is lifestyle thrift. It reflects on the individuals who adjust their spending and saving habits based on their lifestyle preferences. So here we keep in mind both the spending and saving. Like, we have a balance in it. So this balances the financial discipline with personal enjoyment. Like, we are not compromising the personal enjoyment or comfort. Also, we make sure that we like save. Also, people make sure that they save, and they don't overspend. So the research question here is, how do these different dimensions of thrift behavior, that is careful spending, saving, and lifestyle thrift, individually and collectively influence the level of financial literacy among the college students? And to what extent do these behaviors shape their ability to make informed financial decisions? See, the objectives are like analyze the relationship between financial literacy and these thrift behaviors, and determine if financial literacy promotes better saving and less impulsive spending. So a quantitative approach was adopted, and to examine the relationship between the financial literacy and the thrift behaviors. And we made a questionnaire, like a structured questionnaire, and we like sent out to the college students, and through that we got our we got the results analyze. And the analysis tool that we used here is regression analysis, and the data structure was, like I said, it was self-administered questionnaire that was distributed. So it was anonymous. It was the method allowed the participant to respond anonymously, so that there is no bias in it. And the key findings are these are the key findings. As you can see, we the key findings for the thrift behaviors are here, that is careful thrift, spending thrift, and saving thrift. And as you can see, the careful thrift is positive, that is beta 0.3058, and for spending thrift it's negative, and the saving and lifestyle thrift is also positive. So here it states that financial literacy, it really improves careful saving and lifestyle thrift by reducing careless spending. The study also confirms that financial literacy, like, it really plays an important role in shaping the students on how to manage money and spend money and save money. So students with financial literacy make more like cautious decisions, and they make more informed decisions about their spending and saving. And people, as we saw, students with good financial literacy, they save more consistently, and they adapt spending to much long-term lifestyle priorities than like for short-term goals or benefits. And this also gave us this like also like showed us a reduction in impulsive spending. The core insight about this is empowering students with financial knowledge is not just about teaching budgeting. It's also about cultivating a good lifelong behavior that can give them financial independence and resilience. So implications, what kind of implications like the education education system can make, that is they can bring in the financial education into their curriculum to give the students an early habit of saving and on to how to spend and manage their money. And they can also the education system can also help the students to they can teach them on how to use these applications and simulations so that they get to know how to work with the money in the real world. And what can be practical recommendations are the campus level workshops can be done, and mentoring can be given on budgeting and saving, and promoting internships and work time part-time work, which is like very important, and I think that's very practical also. So once you get into jobs and once you do internship, you will really know on how to manage money and how to like save, on where to spend, on what to spend. So once the students get these kind of trainings or like workshops or internships in their college, I think it would be really helpful for them when they hit the early adulthood or their job life. They'll know how to manage the money. And students can also track their expenses and goals through digital tools. I think students can use Excel on to like to note down what they spend on, or how much they're saving and how much they are they have in hand, or anything. They can use Excel for that purpose. I think it's very simple and easier. So thank you all. So this was my paper about, and if anything you can ask me.
Samyukta.
Yeah, yes, ma'am.
Yeah, just a question. When you took the database, I mean the initial data set which you took for analysis, right?
Yeah,
Was
yeah.
it incorporating, since you mentioned in the practical implications and the proposed tools and the aspects you can take over for financial literacy for the college students, did you incorporate gender, age, the already undergrad programs they are covering? If a
Yeah,
child is
yeah, I did.
already, did
Yeah,
you?
yeah, I did, ma'am.
So, if a child is already studying a course on finance, how will it differ in your result and analysis from a student who is not studying a course or a subject on finance?
No, ma'am. So my questions about the financial literacies, it was all about banking, like how they deal with banks, like since
Yeah, yeah.
people.
That my question is, suppose a student, because more than 50% of the undergrad programs right now in the country are already having courses on finance and banking as elective or as a major. Now, did you incorporate that kind of information in your data set that are already literate on it? Or is it focused only on courses which doesn't incorporate the subjects in the curriculum?
Ma'am, can you come again? I didn't get you.
I mean, see, there is suppose there are two kind of course curriculums, X and Y. The X is already having a finance-related subject in its curriculum, and Y is not having. So, will not that be a biased analysis?
Yeah, yeah. But we like mostly I focused it on like UG arts courses, but
Hmm.
I didn't actually I didn't like you said, I didn't like confine it to it. Maybe I should have done that.
Yeah, because even in schools with skill subjects in class 9 onwards till 12, we already have banking and finance as one of the subjects which most of the schools are now taking. taking up. So I think there should be a component of the curriculum also in it, whether they are already
Okay, okay.
knowing it or not knowing it. That's a suggestion.
Okay,
Yeah.
I didn't like, yeah, I get it. I got your point. I mean, but I just like circulated these questions to the all the undergraduates, but I get it. Like, some people might also get finance courses, like you said, in their curriculum, but some students might not get.
Hmm. Because the mean value
Yeah,
gets disturbed.
yeah, yeah.
Yeah, that's okay. Thank you.
Thank you.
Thank you, ma'am, for your presentation. Now there is only one last presentation left. Then we can proceed to the closing remarks. Akanksha, ma'am,
Yes, ma'am. My voice is
are you
audible?
in a stable environment right now?
Yes.
Because we can still hear a bit of hindrance from your background. Hello?
Hello?
Ma'am,
Yes,
uh,
ma'am. I'm telling last time. Is it visible?
yes, your screen is visible.
Oh, oh. Good morning, everyone. Myself Akansha Jain.
Ma'am,
My
actually, there is a lot of disturbance in your voice. Will it be possible for you to check your microphone or like join from another device or like put on headphones or something?
actually, ma'am, my home is road inside, so some
Akanksha, if you can just move away multiple devices,
yes.
if you're logged in from multiple devices, please log in from a single device if it's possible.
Hello?
Ma'am, hello, ma'am. Now it is visible.
Ma'am, your screen is visible. The issue is with your voice actually.
Hello. Now it is audible.
Ma'am, would you be able to like connect from another device?
Ma'am, yes, ma'am.
Hello, ma'am, it is audible.
Yes, ma'am, we can hear you now. You can start with your presentation.
Okay, ma'am.
Ma'am, just a request to please keep it short and within the
Yes,
time limit. We are already
okay,
past
ma'am.
the time.
Yes, ma'am. Yes. Myself, Akansha Jain, and here I am here to present my research topic: a comparative study of deep learning models for food freshness detection using transform learning. In today's food industry, ensuring freshness is crucial for maintaining safety and quality of fruits and vegetables. So, traditional methods like chemical testing, manual inspection are time consuming, required skilled labor, and not scalable for real time application, real time systems. So that's why I propose a machine learning approach using various types of deep learning methods to identify the particular fruit is fresh or stale. So um, main objective of our project is to classify food items as either it is fresh or stale using computer vision techniques. Uh, uh, then I have used five pre-trained models, which is called as a transform learning methods. First one is ResNet 50. Uh, it is a type of CNN deep learning network with 50 layers, and it skips connection to prevent vanishing gradients. Second method is mobile net V2 transform learning method. It is a lightweight and fast and designed for mobile and IoT devices. Third one is VGG16. It is a particular 16 layer CNN models. Um, then fourth one is Inception V3. It uses mixed filter sizes to handle different textures, different shapes, edges of different type of food images. And last transform learning method is Efficient Net V0. It scales various depth, width, height, resolution of a particular image. So, I trained each model to classify fruit images into two categories, fresh or stale, and the model outputs a probability between 0 and 1. If the value is greater than zero point 0.5, then the food is classified as fresh, and if it is less than 0.5, it is considered as a stale fruit. We use binary cross entropy as the loss function, which is suitable for two class problems. So these are the sample images of fruits and rotten fruit images. We have collected uh, in pre-trained models, approximate 48,000 images were used from ImageNet dataset. And for testing purpose, I have collected 100 plus images from my side, which is taken from webcam camera. And for methodology, collected testing images, then pre-processing, some size resolution, some extra noise I have removed from images, then model initialization, the pre-trained models were used, then feature extraction, then classification, okay, like particular fruit is fresh or stale. For performance evaluation criteria, accuracy parameter is used. Accuracy denoted by number of correct prediction divided by number of total prediction into 100. So this one is the result. Result showed that ResNet 50 pre-trained model provided highest accuracy with compared to other models. And VGG 16 and Inception V3 models gives moderate accuracy. In conclusion, our study shows that deep learning models, pre-trained models, especially ResNet 50, gives a higher accuracy in with compared to other models. They can be used in automated system for food quality monitoring, especially in supply chains and retail. In future work, integrating this system into real-time monitoring tools using IoT sensors in video analysis or in any other type of food like vegetable or normal fruits, normal foods. Uh, so these one are the references. Thank you so much. Hello. Hello.
Thank you, ma'am. Thank you
Yeah.
for your presentation. Are there any questions?
No question, Akansha.
Okay. So thank you so much, ma'am. I am sorry for late introduction.
It's all right, ma'am. Now we will proceed to the closing remarks. I sincerely thank our authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on the behalf of the whole team, thank you for the support during this 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2026. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 7 to 8 months. Kindly cooperate with our team of ICT4SD 2025. And lastly, I also want to thank our session chair, Dr. Bhumi Gupta, for chairing this session. A token of appreciation to the chair on behalf of Team ICT4SD and Global Knowledge Research Foundation and partners.
Thank
Thank
you
you,
so
ma'am, for
much.
your valuable presence.
Thank you, Siddhi. Thank you, team, for such coordination. Thank you so much. I've been a part of this team for so long back, and the presenters were really good, and they put in a lot of efforts in the research. I congratulate each and every one of them. Thank you so much.
Thank you, ma'am, for your valuable insight. Now, just before we end this session, I just want to take a quick snapshot of today's conference. So I request all the participants and session chair to please turn on your cameras so that I can take a quick screenshot. We'll just wait for like 10 seconds for everyone to turn on their cameras. Okay, I've taken it. Now you can leave the meeting. This was a great session. Thank you, everyone.
Thank you. Thank you so much.